All right, we're still looking at solutions to systems of inequalities. So let's look at number 7. These are already in slope-intercept form, so they should be pretty easy to graph. So we're going to start with 1. It doesn't matter which one. Let's just start with the first one. So you're going to have plus 6. And then a slope of negative 5. So put negative 5 over 1. All right, and it is going to be a dotted line. Trying to draw a straight line there, okay. And this says less than. So you can see this is a negative slope. It's less than would be this direction. All right, so let's change colors and look at the second one. It says negative 1 is my y-intercept, and my slope is 2. So from here I'm going to go up 2 over 1, up 2 over 1, or I can go down 2 back, down 2 back. Okay, when I look at this one, it says greater than or equal to. Okay, so the first thing I need to do is say equal to means this is going to be a solid line. So the blue line is dotted, the red line is solid, and this one is greater than. So my line's got a positive slope. Greater than is above the line. All right, so I need all points that make both inequalities true. That's the solution of the system, so it's going to be everything inside this blue line. Points on the red line again will be part of the solution as they are solid. As it's a solid line, it's part of the solution. So the shaded region would be all points that are solutions to your system. All right, we're going to look at number 2. This one has y less than or equal to 2. So let's look at it first because that's going to be easy to graph. So I have to go up on my y at 2. And I know I'm going to have a solid line on my y at 2. And I know it's solid because it's less than or equal to. Less than is below the line. So that is easy to mark. All right, for the top equation, I'm going to have to solve for y. Put that one in slope-intercept. So I'm going to bring it down. Let's see if I can change colors here. All right, so to solve for y, I have to divide everything by 8. Okay, since I divided by a positive, my inequality stays the same. This can be reduced by 2, so negative 5 over 4. And 24, 8 goes into 24 3 times. So I'm going to use my y-intercept, 1, 2, 3, to graph that point. And then my slope is negative 5 over 4. So I'm going to come down 1, 2, 3, 4. And then I'm going to go up 1, 2, 3, 4, 5. All right, so this one is greater than, which means there's no equal sign under it. So that means it's got to be a dotted line. All right, so once you have your dashed or dotted line there, greater than is above the line. And the points that make the solution, or the points that make this system part of the solution, is below the red line and above the blue line. So even though in the calculator I showed you before they kind of overlap, I usually just use the arrows. It's just easier, quicker, and it doesn't make a big mess on my paper. So instead of overlapping them, I just use the arrows and then only shade the region that is your solution. You can choose your own way to do it. Just make sure that whichever way you do it, you know which area is the points that make up the solution set. All right, number 9, I'm going to have to solve both of these for y. So let's look at the first one. And I'm going to solve for y by subtracting 3x on both sides. Bring down my negative y. Bring down the inequality. Again, I rearrange these. I always want to have my slope first. And then, since that doesn't have a sign, I know that's a plus 6. And then I don't want negative y, I need y. So that's the same as a negative 1. So I'm going to divide by negative 1 to get rid of that negative 1 and have just y there. I'm going to have y. And then when I divide or multiply by a negative number, I have to swap or switch the inequality. And that becomes greater than. So this is going to be 3x. And negative 6. So I'm going to go ahead and graph this one. So I'm going to have negative 6 is going to be 1, 2, 3, 4, 5, 6. And then a slope of 3 over 1. And I know this is going to be a dashed or dotted line. And greater than, since this has a positive slope, greater than is above the line. It's going to be to the left. All right, so let's graph the second one. So the second one is 3x minus y greater than negative 2. Again, I'm going to subtract my 3x from both sides. I'm going to have negative y greater than, swap my slope and y-intercept here again. That's a negative 2 this time, so make sure you get the negative. And then I have to divide everything by negative 1. Negative 1 divided by negative 1 is positive 1. That leaves just y. Again, when I multiply or divide, I have to switch my symbol. And this becomes positive 3. And 2 negatives make that a positive 2. All right, so I'm going to go over here and I'm going to graph up 2. And a slope of 3. 1, 2, 3 over 1. 1, 2, 3 over 1. It's a good idea to maybe put this over 1 if you forget that it's rise over run. Because if you do 3 over 0, it's going to give you a vertical line and that's undefined slope. So slope of 3 and undefined is completely different. Alright, if I come down here, these two lines look like they have something special. Okay, so this one says y less than. Alright, y less than is below the line. Alright, and then they look like they're parallel. So how do I know if they're parallel? These are parallel lines if they have the same slope. Remember, your slope is the number in front of your x. Slope of 3, a slope of 3. So they look like they're parallel. They actually are parallel. So if you remember, parallel lines never cross. They do not intersect. But we're looking at inequalities, and we need the points above the blue line and below the red line. So the solution to this system are going to be the points between these two lines. And if our graph extended and went beyond and just kept going, we would have that that section between the two lines kind of forever that had points that would work for this system. All right, now we have an application problem we're going to look at. Sarah's pet store never has more than a combined total of 16 cats. So if we look at that, never has more than, That should make you think less than or equal to. All right, so the first thing we need to do is define our variables like we did before. So never has more than a combined total of 16 cats and dogs. So what we're going to do, let's call X is the number of cats and Y is the number of dogs. So if Sarah's pet has a combined total, that means combined, our X's plus our Y's are never more than, so less than or equal to 16. All right, it says she also never, again, never has more than 9 cats. Cats are X, so she's going to have less than or equal to 9 cats. Write a system of inequalities. Okay, we did that. Write a system of inequalities and graph to show the possible number of cats and dogs in her store. All right, now if you see this right here, you see how the X and the Y axis is very close to the edge of the graph. So if you have below the X axis, that's negative. And if you have below, or to the left over here, that would be negative. So we're not going to have negative Y's and we're not going to have negative X's because that would mean we have negative number of cats and dogs. And since we're looking at a real application problem, you have to think of practical solutions and you can't have a negative number of animals. So that's why they've got the X and Y instead of in the middle of the graph, they've got it to the edge because these solution sets won't even exist. So we're going to start by graphing, let's change this one to Y less than or equal to negative X plus 16, and that puts it in slope-intercept form. So let's see how many lines we have here. 1, 2, 3. All right, and then a slope of 1. Sorry, negative 1. All right, less than or equal to, which means this can be a solid line. And I'm not going to draw arrows this time again because it can't go into the negatives here. All right, and then we have X less than or equal to 9. So here's my X-axis. All right. And this would actually continue up. But for this problem, we're just going to be looking at the solution to the system. So we need the part that makes both of them true. So it says the first one is less than 16. Less than 16, but it can't be negative. And then this one says less than 9, but again, it can't be negative. All right, so the solution set for this, for the number of cats and dogs, would have to be above 0, but below these two lines. Now the points on these two sides would be solution sets as well, or points that would make it true. Okay? All right, so if you look and then it's got X is cats and Y is dogs, any of the points in here, any combination, any ordered pair should make both of these inequalities true. Oh yeah, and I went here for X less than or equal to 9. Probably should put this is cats and this is dogs. All right, good luck.